Hello students, myself XI-Sci Gorane, RBNB College Srirampur. In last lecture we have studied 11th science chapter electromagnetic waves and communication systems, and you also know about the electromagnetic waves. Electromagnetic waves consist of electric and magnetic fields. Electric field we denote it by vector E, and magnetic field denoted by B. It consists of electric and magnetic field which are perpendicular to each other and also perpendicular to the direction of propagation. We know the EM wave. Suppose this is the EM wave traveling along the x-axis. Suppose this is y-axis, z-axis. It consists of electric and magnetic field vectors which are perpendicular to each other and perpendicular to the direction of propagation. Electric field vector, we denote it along the y-axis or y direction, and magnetic field vector along the z-axis. These are the magnetic field vectors, that is B, along the z-axis, and electric field vectors along the y-axis. This is EY. And this is BZ, magnetic field along z-axis. Direction of propagation is along the x-axis. This is the direction of propagation, and this is the electromagnetic wave traveling along the x-axis, electric field along the y-axis, magnetic field along the z-axis, and both the fields are perpendicular to each other. Here, electric field is represented by EY. It is along the y-axis, E0 sine kx minus omega t. Electric field vector is represented by EY is equal to E0 sine kx minus omega t, and magnetic field is represented by equation BZ is equal to B0 sine kx minus omega t, where this E0 is amplitude of electric field vector, or it is amplitude of EY, amplitude of EY, and this B0 is amplitude of that magnetic field, or we write it as amplitude of BZ. The electric and magnetic field vectors are represented by these equations. These E0 and B0 are the amplitude of electric field, and B0 is the amplitude of magnetic field. K is propagation constant, and it is 2 pi by lambda. The quantity K is propagation constant. Lambda is the wavelength. Lambda is wavelength of the wave. Omega is 2 pi nu, and it is the angular frequency. Angular frequency, and nu is the frequency of the wave. Nu is the frequency of the wave. Both electric and magnetic fields attain their maximum and minimum values at the same time and at same point. Both attains the maximum and minimum values at the same time and at the same point in space. Hence, we say that this electric field and magnetic field oscillate in phase with same frequency. They attain the maximum and minimum values at the same time. So they oscillate in phase with same frequency. So this is about the electric field and magnetic field. These equations, propagation constant is k, omega is the angular frequency of the wave, and the both waves are in phase with same frequency. And we also know the properties of these electromagnetic waves. So this is about the electromagnetic wave which travels along one direction. That direction is perpendicular to both electric and magnetic fields, and that electric and magnetic fields are also perpendicular to each other. Now we see what is the electromagnetic spectrum. Electromagnetic spectrum is the orderly distribution, or it is the sequential arrangement, of electromagnetic waves, EM waves. Sequential arrangement of electromagnetic waves according to their wavelengths or frequencies. According to their wavelength or frequency in the form of distinct groups. In the form of distinct groups having different properties. Having different properties is called as electromagnetic spectrum. The electromagnetic waves are sequentially arranged, sequential arrangement, according to their wavelengths or frequencies in the form of different groups having the different properties is called as electromagnetic spectrum. The properties of different types of electromagnetic waves are different. The properties are different. So these electromagnetic waves are arranged according to their frequencies or spectrum, different wavelengths, in different groups having the different properties. Now we see the electromagnetic spectrum. It consists of gamma rays, then X-rays, gamma rays, X-rays, ultraviolet rays, we call it as UV rays, then visible light, infrared rays, that is IR rays, visible light, IR rays, microwaves and radio waves. These are the electromagnetic waves, and this is the electromagnetic spectrum. They are sequentially arranged according to their wavelengths or frequencies in the form of different groups having the different properties. Now see here, gamma rays, if we consider a frequency and wavelength, frequency of these gamma rays is very high frequency, and frequency goes on decreasing, and frequency of radio waves is low frequency is low. Gamma rays frequency is high, radio waves frequency goes on decreasing from gamma rays to radio waves, frequency of radio waves is low, whereas the wavelength of gamma rays is low and wavelength goes on increasing from gamma rays to radio waves. For radio waves, wavelength is high. They are arranged according to their frequency or wavelengths. There is inverse relation between frequency and wavelength. For gamma rays, frequency is high, wavelength is low. And as we go downwards, frequency of radio waves is low, but its wavelength is high. Now see here, this part of the electromagnetic spectrum is visible to us. It is called as visible light. And this visible light consists of colors from violet to red, or different colors, violet to red. These colors are there, violet, indigo, blue, like this. This is visible to us. This part is invisible. This part is also invisible to us. Only the part visible to us is this visible light from colors violet to red. The spectrum or the rays or the electromagnetic waves having wavelength less than violet is ultraviolet. Wavelength less than violet is ultraviolet. Wavelength greater than red is infrared. Wavelength less than violet, ultraviolet. Wavelength greater than red is infrared rays. This part is only visible to us. This part is invisible. This part is also invisible. And depending on these groups, their properties are different. So this is the electromagnetic spectrum. They are arranged according to their frequencies or their wavelengths. Now the frequency of the wave, SI unit of the frequency is hertz. Frequency is measured in hertz. SI unit of frequency is hertz, whereas unit of wavelength is meter. Some larger units are also used: kilohertz, megahertz, gigahertz. 1 kilohertz is equal to 10 raised to 3 hertz, that is 1000 hertz. 1 megahertz, 10 raised to 6 hertz. Then 1 gigahertz, 10 raised to 9 hertz. SI unit of the frequency is hertz. We use the higher units. Conversion factor is like this: 1 kilohertz is 10 raised to 3 hertz, 1 megahertz is 10 raised to 6 hertz, 1 gigahertz is 10 raised to 9 hertz. Similarly, the SI unit of wavelength is meter, and we also use some smaller units: 1 micrometer, 10 raised to minus 6 meter. 1 micrometer is 10 raised to minus 6 meter. 1 nanometer is 10 raised to minus 9 meter. 1 angstrom unit, 10 raised to minus 10 meter, or this is also 10 raised to minus 8 centimeter. These are the some small units of the wavelength. SI unit is meter, and this is the conversion factor between this micrometer, nanometer and angstrom unit with that SI unit. Now properties of this electromagnetic spectrum is different. Their method of production is also different. We see properties, method of production and uses of the electromagnetic spectrum. Firstly, we see the radio waves in the spectrum. Radio waves. Radio waves. Now these radio waves is electromagnetic wave, or it is a part of the electromagnetic spectrum, and they are produced by the accelerated motion of charges. Production by accelerated motion of charges in a conductor. We know that electromagnetic waves are produced by the accelerated motion of the charges. Similarly, these radio waves are produced by the accelerated motion of the charges in the conductor or conducting wire. Frequency of wave produced by the circuit, frequency of these radio waves depends on value of inductor or inductance L and capacitor C. And capacitor C, inductor and capacitor C. The frequency of radio waves produced depends on magnitude of inductance L and capacitance C. By using suitable values of these L and C, radio waves of desired frequency can be produced. We can produce radio waves of desired frequency by selecting the proper values of this inductor and capacitor. So this is about the production of these radio waves. They are produced by the accelerated motion of the charges in the conducting wire. The frequency depends on the value of inductance and capacitance in a circuit. And by using the suitable values of L and C, we can produce the radio waves of desired frequency. Now we see some properties of these radio waves. Properties are very simple. Properties of radio waves. These waves are having very long wavelengths. Long wavelengths. It means its frequency is low. These waves having very long wavelength, its frequency is low. Wavelength is from few centimeter to few hundred kilometer. Main property is wavelength of the radio waves is very large in the spectrum. It ranges from few centimeter to few hundred kilometer. As wavelength is large, the frequency is low. Then next property is frequency range of AM waves, amplitude modulated radio waves. The frequency range of AM waves or AM band is 530 kilohertz to 1710 kilohertz. Amplitude modulated waves or AM band radio waves, the frequency ranges from 530 kilohertz to 1710 kilohertz. They are used for TV transmission signals. The radio waves are also used, and here the frequency range is 54 megahertz to 890 megahertz. For television transmission, the frequency range is 54 megahertz to 890 megahertz, and for FM radio band frequency modulation, radio band, the frequency range is 88 megahertz to 108 megahertz. Long wavelength is there. Frequency range for AM band is this much, 530 kilohertz to 1710 kilohertz. For the transmission of the television signals, the frequency range is 54 megahertz to 890 megahertz, and for FM radio band, the frequency range is 88 megahertz to 108 megahertz. So these are the some properties of these radio waves. Now we see uses of these radio waves. Uses of the radio waves. First main use is, it is used in wireless communication. Wireless communication. We know that cell phone also uses the wireless communication. There is no wire between the two cell phones. The communication is wireless communication, that is there is no wire. Without wire, the communication is there. Due to these radio waves, radio broadcasting and transmission of television signals. Used in radio broadcasting and transmission of television signals. Television signals. Radio waves are used. The next use of these radio waves is cellular phones, that is mobiles. The mobiles uses the radio waves to transmit voice communication in ultra high frequency band, UHF. Ultra high frequency band. In cellular phone, for the transmission of voice signals, radio waves are used to transmit these signals in UHF band, that is ultra high frequency band. So this is about the radio waves, its production, properties and uses. Now we see the microwaves. This is also a one part of electromagnetic spectrum. Microwaves. Microwaves. This is one part of the electromagnetic spectrum. Now we see how it is produced, its production, then its properties, and then we see its uses. Produced by the oscillator electric circuit. Oscillator electric circuit containing inductor and capacitor. Containing inductor L, we know inductor L, and capacitor C. Production of these microwaves is they are produced by the oscillator electric circuit containing inductor L and capacitor C. They can also be produced by the special vacuum tubes. Special vacuum tubes. By using special vacuum tubes. Vacuum tubes are the semiconductor devices. By using the special vacuum tubes, these microwaves can be produced. Now this is the production of these microwaves. Now we see its some properties and then its uses. Production method is by using inductor and capacitor. By changing the value of that L and C, we can change the frequency of that microwave also. Then we see the properties of these microwaves. Properties are different from the radio waves. Properties of each part of the spectrum is different. Their method of production is also different. But main common thing in between all these is their speed is very high, same as the speed of light. The main property of the microwaves is they hit certain substances on which they are incident. They hit the substances on which they are incident. The substance gets heated. When microwaves are incident on it, they are used for long distance telephone communication. Long distance telephone communication. These waves are used. This is the second property of these waves. One main use we know, we use the microwave ovens. In microwave ovens, these microwaves are used, and these microwave ovens we use for cooking. Microwave ovens. The next is used in radar. Used in radar. Radio detection and ranging unit, called as radar system, for location of distant objects such as ship, aeroplane, etc. These microwaves are used in the radar system. Radar is radio detection and ranging unit for the location of distant objects, that is the objects at very large distance, such as ship, aeroplane. Microwaves are emitted from the source. They are reflected from that object, and by using the formula velocity is equal to distance upon time, that distance we can calculate the distance of that distinct objects by using the microwaves. Then fifth usage, these microwaves are used in study of atomic and molecular structure. Used in study of atomic and molecular structure. They are used in cooking, transmission of the television signals. They incident on the substance can be heated. long distance communication. In property 1, property is also there. This is first property, they hit the substances on which they are incident. Second property is they can be detected by the crystal detectors. Detected by crystal detectors. These two are the properties. They hit the substance on which they are incident. They are detected by the crystal detectors, and these are the uses. They are used for the long distance telephone communication, transmission of television signals, also used in transmission of TV signals. These are the uses, and these are the properties. They hit the substance on which they are incidents. They are detected by the crystal detectors, used for long distance telephone communication, used for transmission of television signals. Microwave ovens are used for the cooking, used in radar system for location of distant objects such as ship, aeroplane, etc. And they are used in study of atomic and molecular structure. So these are the some properties and uses of these microwaves. Today we stop here. Thank you.